All right, let's see here. Path distance of passes and queries in a graph part 1. If I previously solved this, medium. You're given integer n representing the number of nodes in a graph labeled 0 to n minus 1. Okay. You're given an integer array num of length n sorted in non-decreasing order. An integer max diff. An undirected edge exists between nodes I, j if the absolute difference between nums at I and nums at j is at most max diff. So an edge exists between two nodes if the value at those nodes, or let's say at the two indices in the array, if the values at those indices are less than or equal to, okay, yep. You're given a 2D integer array queries where each query at I equal to u comma v. Determine whether there exists a path between nodes u and v. Return a Boolean array and answer where answer at I is true if there exists a path between u and v in the ith query. Okay, I think I understand. So 2 nodes. Num. So these are like positions, kind of. So the nodes are at position 1 and 3. The max difference is 1, so there can be an edge that is 1 apart between. So if the nodes are at positions that are at most 1 apart, then there's an edge between them. So there's no edge between these 2 nodes. So between nodes 0 and 0, then obviously that should work, so that should be true. Between nodes at indices 0 and 1, that should be false. Okay, positions of node 0 is at 2, node 1 is at 5, node 2 is at 6, node 3 is at 8, 2. Doesn't have to be in, oh, it is in non-decreasing order. So these values are always going to be increasing, okay? Or not decreasing, so increasing or tied order. So there's no edge between 0 and 1. There is one between 1 and 2, and between 2 and 3. Okay. I was originally thinking I would need a graphing structure, or generally with graphs, I would use some sort of process stack and process for each node all the neighboring, but this one seems like just a linear pass would work. Yeah. Like technically if I think about this being on a line, there'd be just connection between these and then connection between these. So there's like a single line between these. Just like that, like 1 to 2 to 3. Sure. I think of well, then I can formulate how these things are connected with a single linear kind of pass through the values at the positions of those nodes, the positional value of the nodes. Can this be done in constant time given that information? I think so. So I'm guessing this should be linear time. This suggests that it could be done in sorted time or linear time, 10 to the 5th. All right. I think I just use a stack to process how far maybe from one node it connects. So like, let's say let's say farthest equals is an array, farthest array, where the index into the array equals the kind of starting node slash position, and the value at the index in the array is the farthest kind of leftmost or rightmost farthest index that it connects to. Because, like for instance, if the indices, let's say the indices are going to be 0, 1, 2, and 3, the farthest that 0 can go to is 0. Like it can't really, it's always just going to connect to like the leftmost, or it's always going to connect to the right or left of it. And then from that one that node connects to the left, right of it. So I can just say, if I assume that this is the starting node, how far it goes. I think that works. I think why not there's a better data structure for that, or a better way of containing that information. I think that's the simplest way of, yeah. Say farthest, n is the length of nums. Nums is n, actually, sorry. N is already pre-given. Yeah, okay, yeah. For every, let's say the current position. I think I need to have an index, or let's say the f index is the farthest index. So for every index k in range n, I'm going to say the current position is nums at this index, and then I'm going to move as far as possible. So while I think I need to move at least the farthest index has to be equal to, at most, has to be starting from at least one after this one. So I think it's going to be k, the current farthest index, and k plus 1. So I need to at least have it be the next element. I guess this should be the maximum. So if my current index is k is 0, then this thing should start out with like basically 1. I start out with 1 here. And then if, I guess it'd be while the current position, no, I should be comparing the connection. So while there's a link between the node at f index and the node at f index minus 1. So while max diff, or while nums at f index minus nums at f index minus 1 is less than or equal to max diff, and that means there's a connection between those two nodes. Then I can do f index plus equals 1. So then I jump all the way down to where the link stops. And where the link stops, then the farthest it can go is f index minus 1. So then farthest appends f index minus 1. I think that's right. And technically I need to backstop it so that it doesn't go out of bounds. So I think I need nums append infinity so that it always will stop at the last, not being linked up to a position at infinity. Okay, I think at that point I can go for every, because queries doesn't have to be sorted, right? Yeah, queries just can be arbitrarily kind of randomly ordered. So for every, say, I guess I can just go iterate using a for each loop. So for each, yeah, u and v doesn't have to be small and largest. So let's say u, v in queries. I guess I should probably sort u and v. U, v equals u. I don't think I can actually do this, right? Yeah. I can't do double assignment with an if statement, I don't think. Maybe I can actually. U, v equals u comma v if u is less than or equal to v, else v comma u. Can I do that? I don't know if I can do that. Otherwise I have to do kind of a bigger if statement rather than one liner. All right. So assuming that u and v are increasingly sorted indices in the query, I just can say answer this answer is going to be true or false, right? So answer appends if say able is going to be for this query farthest of u is less than or equal to v. So however far you can go here from this position, I guess it'd be greater than actually. Greater than or equal to v. So 0, 2. Yeah, I think that might be right. And then just answer appends whether or not it's able to do this query. Oh, now let me double check whether or not I can do a wrongly sorted query. So 0, 1, 1, 0. So it can do wrongly sorted queries. Let's just try the second test case. Say 3, 1 here. 3, 2, 2, 0. Okay. I guess it seems okay. That's kind of slow, huh? I mean, that's not even kind of slow. That's just slow. I mean, I feel like this is, this is kind of like an if statement. There's like 2 if statements inside this for loop. There has to be a better way. Yeah, there has to be kind of a better way. Or I need to not do so many if statements here. Yeah, maybe I should do 2 pointers without for loops. Use while loops here, like an outer while loop and inner while loop. Because whenever I detect that it has a gap, every index before that gap should just use index minus f index minus 1. Okay, so I think should be I should say k equals 0 maybe. Let's say k is the current index, f is the farthest index, or say k is in bin and 1 current index. In means current index, and fin means farthest indexed. So while n is less than or equal to or less than n, and then while, no, this should be starting at 0. While nums at fin is minus nums at current index is less than or equal to max diff, then actually, why do I need, I think I just need a current index, to be honest. Yeah, I just need a current index. Whoops. While current index, while nums at the current index plus 1 minus nums at the current index is less than or equal to max diff. Then farthest appends. Oh, I don't know the actual thing. I don't know the actual NA index. I see. I know that I need to iterate over them. I guess I just do a count, huh? Then the count is going to increment And so will I guess this is just too much. Okay, so let's say the start. Okay, so I'm setting an initial marker for where I start this group of connected nodes. And then once I figure out how long this is before it jumps, then Ken should really be, so max diff, so it could be 0, could be 0, because this thing can be already too far. That's fine. Then I do like farthest is gonna append, this should be n plus 1. No, this should be not append, this should be extend. It's going to extend by a number of this times the number of the difference between the start and the end index. So it's something like kin minus start plus 1. All right, I think that might be a faster version of creating the farthest array. Bartus. Nothing like that, actually. Nope, it goes infinite, huh? This goes infinite. So let's say kin starts at 0, 0 less than 2, start index is 0, nums at 1 minus nums at 0 is less than or equal to max diff, which is false. So that breaks. Farthest extends by 1 times. Okay, this thing needs to have this thing needs to actually have some movement. I think this needs to have a kin plus equals 1. Shucks cahoots. True everywhere. Guess I should probably print out the farthest array now. What exactly am I producing? The farthest of this thing is 1. Farthest of this thing is 2. I guess this previously it was inclusive of it. And now it's exclusive. Yeah. Farthest of this thing is, yeah, this is not the logic or inclusive and exclusive as before. So I think this should be, it should just do kin, not kin plus 1, because kin plus 1 is not inclusive of the last, or I intended for this to be inclusive of the index at the last rather than exclusive, or the previous code did that. Okay. I think this is fine. I should probably just call this current index or just index. Huh? I had in just because I always had like a farthest index and a current index, but now it's just index. Okay, I think that should be. I wonder if I need to remove this if statement right there or make it slightly better. Still too slow. So yeah, queries is not like it's, there's no ordering in queries, I don't think. Hmm. I wonder if there's a better way of constructing this farthest. Extend. I mean, I could do two passes. One pass to determine the farthest index for every index, and then, or one pass to go where the breakpoints are for the farthest. Another pass to just iterate over and kind of input those values into an array multiple times. Um, I guess maybe this is a little slow right here for every UV in queries. I can do is just if u less than or equal to v, or I guess if u is greater than v, then uv equals vu. I guess that's might be slightly better. And answer just appends when not farthest of u is greater than or equal to v. Just slightly more condensed logic there. Oh man, I'm just not getting over this hump. Hump. I think this is fine for this index. Well, index less than or equal to n. Start. Well, num's at index plus 1. This is basically like an O of n loop. Less than or equal to max diff index increments. So this loops until it finds that it needs to jump or it doesn't connect. Then extends up to this index. Then moves up at least once after that. Okay, I'm done. Okay, summary. So since the since the positions of the nodes, nodes are ordered, can consider the nodes to be on a kind of 1D line, on a single kind of coordinate line. And links between successive nodes can be formed as long as the difference between those positions are less than or equal to the max diff. Thus, for a node, let's say x, it can link to some later node kind of y, like let's say x is 10 and y is 20, as long as every node between x and y is less than or equal to max diff in difference, the position between them. Thus, create some farthest array where kind of index equals x and farthest array at that index equals y. Use a loop to iterate over the positions of the nodes, appending to the array or extending to the array the farthest position connected. And that was this thing right here. So basically your index, let's say 0, you're going to iterate through the indices until you find that there's a gap. So say 0 is connected to 1, 1 is connected to 2, 2 is connected to 3, 3 connected to 4, so on and so forth. Let's say it goes all the way up to index 10, or index 10, or index 10 plus 1, index 11 is of a bigger than max difference from index at 10. So at that point, you extend for all the nodes between 0 and 10, I guess, something like that, the value at the last index. So 0 can go to 10, 1 can go to 10, 2 can go to 10, because everything up to then, 10 can go to 10. And then index 11 will kind of be its own deal, because there's a gap between 10 and 11, right? And then use that or this array to answer the queries, to kind of sort the queries in small or larger order. So because u and v doesn't necessarily need to be, isn't guaranteed originally to be u is less than or equal to v, or u less than or equal less. Yeah, it could be in the reverse order. So just order it before you do the usage of the farthest array. All right, time complexity is going to be O of n, where n is the length of, actually this is probably O of n plus m, where n is the number of nodes, and m equals number of queries. Yeah, because you're doing one pass to get the farthest array, which is going to take n steps. This thing technically increments at least once each loop. And then obviously you go through all the queries. And then space of x be O of, technically if it's O of n, then we're since using a farthest array, which will have n indices, the farthest of each index. All right, Colleen.